So there's a method to solve quadratic equations that requires you do some algebra manipulation, and this process is called completing the square. So, and you do this when you are trying to basically factor something that isn't otherwise factorable. So it gives you an example. Let's see here, and basically if you took x squared plus 6x, it's missing the unit tiles, right? This would be like x plus 3 times x plus 3. So in the middle here, right, this should be 9 unit tiles. 9. So if you were to actually have all of these tiles that you need, right, you'd have 1x squared, 6x plus 9. So you're definitely missing something. So this is a trinomial, which is an example, let's see, of the special case, which is, right, this is technically a review from chapter 5. It's also on a poster that I kept referring to past week or so, special case polynomials, right? This is on the poster, special case polynomials, and it's a poster up on the wall. If you have a condition where it's a plus b squared, it's going to be a squared plus 2ab plus b squared. So recall that the trinomial of this form is called the perfect square trinomial, and that winds up being like 1x plus 3 squared, 6x, and 9. So now let's take a look at another example. This here has, well, on top it would be 2x, on the side it would be 2x, and this is plus 2 and plus 2. So you have the same condition, right? You're missing your 4 unit pieces. So this would be 4x squared plus, it looks like 8x. So you're trying to complete the square. If what's occurring is you're trying to make this perfect square trinomial, and you're missing something, right? It's plus the missing stuff. You would have to add, right, in this case, 4 tiles to this. So hopefully everybody's with me so far, so good. And in this case, right, I'd have to add 9 tiles. So hopefully you can't hear the leaf blower going too loudly on this video, but as you can tell, it is approaching my door. It's about what I have to look forward to at about 6:20 in the morning. So give you a chance to write all this down, and then we'll move on to the next section. So continuing on, right, we are trying to get to 4x squared plus 8x plus 4. So the trinomial is the square of the binomial, right? There's this thing, and that's the result of 2x plus 2 squared, right? Or 2x plus 2 times 2x plus 2. And I'm just going to switch pages, right? That's what we determined right here. So that's what's happening there. Now, completing the square is a process of rewriting the quadratic expression as a perfect square trinomial, so it can be solved by taking square roots. We learned about using square roots to solve quadratics in the previous section, 9.1. And in this case, you're going to take basically a quadratic that's missing its unit pieces, and you're going to do a process to add the unit pieces back to the problem so that it could be factored and then solved using the square root. And I know that all sounds like a ton of stuff, but let's take a look. And when you do a few examples, like anything else, it'll make more sense. So recall that the standard form, right, the standard form of a quadratic is ax squared plus bx plus c. And in this case, right, here's a, here's b, and the c part is missing, right? So we're going to add it by the process of called completing the square. So in this scenario, right, a is equal to 1, b is equal to 8, negative 8, right, negative 8, and c, don't know. That's actually what we're going to try to figure out. So if b is negative 8, the process for completing the square is essentially taking whatever b is, dividing it by 2, and then squaring it. And this is going to be what I need to add to both sides of the equation. My brain was thinking the future equation. So here we go. Well, negative 8 divided by 2 is negative 4. And 4 squared, I should say this is negative 4, and negative 4 squared is going to be 16. So in order to basically complete the square, and complete the square means essentially turn the problem into a perfect square trinomial. Gee, I wonder why I called it completing the square instead of turning the problem into a perfect square trinomial. But right, that's essentially what you're doing when you're completing the square. You are adding something, right? You are adding something so that you can then factor this into that condition where it's like a plus b squared is equal to a squared plus 2ab plus b squared. Or, right, this other condition, a squared minus 2ab plus b squared. And these are both posters on the wall. So hopefully this is going to make some sense as we do more. And I have a feeling that it's going to be a long section of notes. We might probably do it over a couple days. So in this section of notes, we're going to do an example, right? Here's A, here's my B. The C is the part I'm trying to figure out. So recall, right, to complete the square, you got to take B divided by 2 and square it. So what is 12 divided by 2 squared? Right, that's going to be, well, 12 divided by 2 is 6, and 6 squared is 36. So if I basically take x squared plus 12x plus 36, this can now be factored into x plus 6 squared. So now we're going to actually use this completing the square process to help us find the values for x and solve a problem. Now this problem would be easy enough if it was simply, let's say, x squared equals 36. You would take the square root of both sides like you did in last chapter, and x would be plus or minus 6. But that's not what this is, right? This is something different. So we're going to attempt to solve this by essentially completing the square. So if this is A and that's B, we're trying to figure out, well, what do we need to add to make this work? So I'm going to take, right, remember the process was B divided by 2 squared. So what is 16 divided by 2 squared? Right, that's going to be 8 squared, and that's going to be 64. So I need to essentially add 64 to both sides. And I can do this because as long as I add or subtract or whatever I do to both sides of the equation, that's totally allowed in algebra. In fact, that's like most of algebra, manipulating the equation to get to where you want to be. So, right, we've got the 1x squared, we've got the 16x, and now we're going to add 64 to both sides. And you'd be like, well, why am I doing this? Well, this is where it's going to come in handy, right? So x squared plus 16x plus 64 now can be factored. This is going to be 1x plus 8, essentially squared. And all that's equal to the sum of 64 and 36, which is 100. And now I can solve for x very easily now that I've completed the square, because I simply take the square root of both sides. You're going to get x plus 8 is equal to plus or minus, well, what's the square root of 100? 10. So you're going to have basically 1x plus 8 is equal to positive 10, or 1x plus 8 is equal to a negative 10, right? And that's supposed to be a negative right there. And now subtract 8 from both sides. X is either 2 or x is negative 18. And now we can see, well, let's plug in these problems or these solutions back into our original equation. So here was our original equation, x squared plus 36, not 36, plus 16x equals 36. And let's see if it works. Is 2 squared plus 16 times 2, is that 36? Well, 16 times 2 is 32, and 2 squared is 4, so that's definitely 36. So this one checks out. And how about negative 18? We got negative 18 squared plus 16 times negative 18. Is that equal to 36? Let's probably have to bust out my calculator for this one. Let's see, what is 18 squared? 18 squared, you got 324 plus 16 times a negative 18. And that one checks out. It is also 36. So this next part has us basically checking our answer, which is something I just did. So negative 18 squared is 324, and 16 times a negative 18 is negative 288, and that makes 36 is equal to 36. So this definitely is a solution. And for this one, you're going to get 4 plus 32, and this also is a solution. So now let's try two examples. This is A, that's B. To complete the square, I got to take B, divide it by 2, and square it. So you're going to get basically negative 10 squared divided by 2 squared, and that's going to be 100 over 4, which is 25. So I add 25 to both sides. X squared minus 10x plus 25 is equal to 11 plus 25. And from here, this is going to factor into x minus 5 squared. squared. And all that's equal to 11 plus 25, which is 36. The next step, the inverse of squaring something is to take its square root. So you're going to get x minus 5 here. The square root of 36 is 6 plus or minus 6, I should say. Let me rewrite that. Plus or minus 6. So x is going to be equal to basically 6 plus 5, or x is going to be equal to negative 6 plus 5. So one answer is 11, and the other answer is negative 1. So that's the work for that one. One more example, a, b, take b, divide it by 2, and square it. Now you're engaged in the process of completing the square. Or, right, my other name I like to call it was, what was it? Oh well, I'm sure it'll come to me. 6 divided by 2, you're going to have on the top, what is 6 divided by 2? That's 3. 3 squared is equal to 9. So I have to add 9 to both sides. X squared plus 6x plus 9 is equal to 2 plus 9. This here factors into x plus 3 squared. 2 plus 9 is 11. The next step, take the square root of both sides. X plus 3 is equal to plus or minus the square root of 11. That is still a number. Do not discriminate against radicals. They are numbers too. They're not nice numbers like integers, but they're definitely an approximate number on your calculator. So here we go. You're going to get two solutions, right? X is going to be equal to essentially a positive square root 11 minus 3, or x is going to be equal to a negative square root 11 minus 3. And these are actually the answers I prefer in radical form. If you give me the decimal is simply an approximation, but these are exact.